Welcome to Fact Flow. Your journey into the hidden corners of the universe begins right now. Today we dive into the icy blue twilight of the solar system, where sunlight is weak, time moves slow, and a tiny world has sparked one of the most emotional scientific debates of the modern era. That world is Pluto, once our beloved ninth planet, now reclassified as a dwarf planet. But the story of Pluto is much more than a label change. It is a tale of discovery, of mystery, of scientific evolution, and of a world far more alive than we ever imagined. In this video, we peel back the layers of Pluto's past and present, from its discovery and demotion to breathtaking revelations from NASA's New Horizons mission. This isn't just astronomy, it's a story filled with wonder, surprise, and cosmic intrigue. Journey with us. For decades, Pluto held a place of honor in textbooks, classroom posters, and the imaginations of millions. Children memorized the 9 planets with pride: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, the mysterious ice world at the edge of everything. Why did this tiny sphere, smaller than Earth's moon, earn such affection? Perhaps it was its distance, a lonely wanderer in the far, frozen dark. Perhaps it was the thrill of discovery, or maybe the comfort that even the smallest among giants still counted. Pluto represented more than facts. It represented belonging. To understand how Pluto captured human hearts, we journey back to the early 20th century. During that era, astronomers believed another world, a hidden planet X, disturbed the orbit of Neptune. Something massive, they thought, must be tugging on the outer planets like an invisible hand. The search began. Observatories scanned the skies night after night, looking for something faint, distant, almost impossible to see. And then, in the winter of 1930, a young observatory assistant named Clyde Tombaugh found it. Imagine this moment. A young man, barely past adolescence, hunched over photographic plates, comparing stars that barely moved. Then, there it was, a tiny dot shifting slightly between frames. A new world. A planet. Humanity cheered. Newspapers exploded with headlines. The solar system had grown. But here was the secret. Pluto was not the giant many expected. It was small, astonishingly small. The early excitement made astronomers overestimate its size, thinking it might rival Earth. It was not until later that we realized Pluto was only a fraction of our moon. Yet the name was chosen quickly and perfectly. 11-year-old Venetia Burney proposed Pluto after the Roman god of the underworld, fitting for a world cast in darkness. For more than 75 years, Pluto remained planet number 9, floating at the frontier like a lone sentinel. Its orbit, however, was already raising questions. Unlike the near-perfect circular orbits of most planets, Pluto travels in a stretched oval, tilted 17 degrees away from the solar plane. Sometimes, incredibly, Pluto even comes closer to the Sun than Neptune. A planet behaving this strangely challenged tradition, but because no other similar objects were known then, Pluto kept its crown uncontested. The turning point was yet to come. Astronomers explored deeper into space and began detecting objects that resembled Pluto. Icy, rocky bodies drifting in a vast ring beyond Neptune. This region would later be named the Kuiper Belt. Pluto, once unique, was suddenly one among thousands. That realization would spark the biggest identity crisis in our solar system. Yet even as science evolved, the world remained attached to Pluto. It was the underdog planet, small, cold, knocked from power, but never from memory. The emotional connection persisted because Pluto reminded us of ourselves, insignificant by size, yet bursting with story. A tiny world defying expectations, waiting patiently in the cosmic dark for someone to come closer. That moment would finally arrive in the year 2006, the same year Pluto's status was challenged. While scientists debated definitions, a spacecraft named New Horizons left Earth, racing toward the most distant reconnaissance mission in history. Pluto was about to speak for itself, not through classification, but through revelation. A lost planet, or a misunderstood world waiting to surprise us? The icy silence of space held the answer. Long before we knew Pluto's true identity, astronomers were driven by a kind of cosmic suspicion, the idea that something unseen lurked beyond Neptune. Subtle discrepancies in planetary motion hinted that another large world might be disturbing the gravitational balance of the solar system. They called this mysterious presence Planet X, a phantom planet that existed only in equations and in the dreams of stargazers. The early 20th century was an era of relentless curiosity. Telescopes were growing stronger, photographic techniques more precise, and humanity hungered to expand its boundaries. At the Lowell Observatory in Arizona, this hunger concentrated into a focused mission: to find Planet X. Clyde Tombaugh, young, determined, self-taught, was chosen for the task. Night after night, he exposed glass plates to the darkness, capturing faint pinpricks of light. It was tedious work. Every star looked identical. Every frame shimmered with noise and imperfection. But Tombaugh possessed something more valuable than advanced equipment: patience. He compared plates manually using a device called a blink comparator. Two images of the same sky region would flicker back and forth, and if any point of light moved ever so slightly, that motion might indicate an orbiting body. The human eye became the instrument. And then, on a cold February day in 1930, Tombaugh noticed a tiny speck that jumped between frames. Not a star, something closer, something wandering. This was the moment history shifted. The solar system, once thought complete, expanded again. Headlines shouted the news. Students learned the updated list of planets. Families bought globes with 9 worlds instead of 8, and astronomy felt triumphantly alive. Pluto arrived not silently, but with celebration, a symbol of humanity's growing reach. But here is where the story deepens. What Tombaugh found was real, but what we believed about it was shaped by assumptions. Astronomers assumed Planet X must be large, so when Pluto appeared, they easily fit it into the role they expected. Measurements were crude, distances uncertain, and reflected sunlight made Pluto look brighter, and therefore bigger than it was. Early diagrams exaggerated its size dramatically. Pluto was imagined as Earth-like, even powerful. In truth, Pluto was tiny, so tiny that later, once space telescopes improved, astronomers realized something astonishing. The gravitational irregularities that sparked the search for Planet X were due not to Pluto, but to miscalculations. Pluto was a coincidence, a cosmic surprise, discovered while chasing a ghost that never existed. This revelation didn't diminish Pluto. It made its discovery even more extraordinary. A world found not through perfect math, but through persistence, curiosity, and a bit of universal luck. People bonded with Pluto emotionally, not logically. It felt like a fragile treasure discovered at the edge of night, a reminder that exploration often rewards those who refuse to stop looking. As more powerful telescopes scanned deeper into the Kuiper belt, astronomers began finding many objects similar to Pluto, some smaller, some nearly equal in mass, and eventually one larger, named Eris. Suddenly the question could no longer be ignored. If Pluto is a planet, why aren't all these others planets too? Science was growing, and knowledge demanded clarity. Pluto's story was evolving, not ending. It was about to face an identity trial unlike anything in celestial history. Not because of conspiracy, not because of disrespect, but because the universe had become bigger than our old definitions could handle. The reclassification of Pluto wouldn't just reshape textbooks. It would reshape the way we understand worlds themselves. A storm was coming, quiet, scientific, but powerful. And Pluto was standing at the center. For more than 3/4 of a century, Pluto stood proudly among the planets, a distant, frosty outsider, but one of the family nonetheless. Generations grew up with posters showing 9 planets, and the number felt sacred. But science does not bow to nostalgia. It evolves with evidence. And in 2006, a decision arrived that shook classrooms, news headlines, and childhood memories worldwide. Pluto was no longer a planet. To understand why, we step into the conference room of the International Astronomical Union, the IAU, where scientists gathered to answer a deceptively simple question: what is a planet? Strangely, for all of human history, the word planet had never been officially defined. We used the term casually, assuming we all meant the same thing, until discoveries made that impossible. As telescopes revealed more bodies drifting beyond Neptune, Pluto's uniqueness began to dissolve. If Pluto remained a planet, logic suggested that dozens more should join the list. Suddenly, the solar system would not have 9 planets. It might have 50 or 100 or even more. The universe was expanding in our understanding, and definitions needed to catch up. 3 key criteria were proposed. For an object to be a planet, it must 1. Orbit the Sun directly. 2. Be massive enough for gravity to shape it into a sphere. 3. Clear its orbit of other bodies. Pluto passed the first 2 tests easily. It orbits the Sun, and its own gravity rounds it like a marble of cosmic ice. But the 3rd requirement became its downfall. Pluto's orbit is packed with Kuiper Belt objects, icy fragments, debris, dwarf worlds. It does not dominate its neighborhood like Earth or Jupiter. Instead, it shares space with countless others. So Pluto failed the 3rd rule, and with that failure, a vote stripped it of its planetary title. People reacted not with calm acceptance, but with heartbreak. Fans protested. Schoolchildren wrote angry letters. Some refused to update posters. Pluto had become a character, like a beloved friend, and losing its planetary status felt personal. The universe did not shrink, but our emotional connection felt bruised. Yet behind the emotion lies something profound. Pluto's reclassification was not a demotion. It was refinement. The cosmos had become richer, more complex. We no longer saw Pluto as a lone wanderer, but as the first known ambassador of an entire region, a gatekeeper to the Kuiper Belt, a world among worlds. In fact, Pluto's new label allowed it to shine even brighter. No longer forced to compete with gas giants and rocky titans, it became the icon of a new category: dwarf planets, worlds small but fascinating, icy yet dynamic, humble yet mysterious. Pluto did not fall, it evolved, and destiny had perfect timing. In the very same year, scientists tightened the definition of a planet. A spacecraft left Earth, racing into the darkness with one purpose: to meet Pluto face to face. The universe had one more surprise, and Pluto was ready. While Pluto's status was being debated and dismantled, far from the noise of headlines, a spacecraft was already on its way, silent, determined, unstoppable. New Horizons launched in 2006, the very same year Pluto was reclassified. Almost poetic, isn't it? Humanity removed Pluto from the planetary throne, yet simultaneously sent a messenger to discover its secrets. It was as if the universe whispered, "Before you judge, go and see." The journey to Pluto demanded extreme engineering. This was not a short trip across the solar neighborhood. New Horizons had to travel billions of kilometers, farther than any mission had ever traveled at launch. To make that possible, it was built light, fast, and hungry for velocity. When it left Earth, it became one of the fastest spacecraft ever launched, racing into the dark at speeds surpassing those of Apollo missions. Earth shrank behind it like a fading spark. For nearly a decade, New Horizons traveled through empty space. No pit stops, no repairs, no second chances. The spacecraft slept for most of the voyage, conserving power, waking only for health checks, like a deep breath before an awakening. Mission Control listened for its heartbeat across the void, each signal taking hours to reach Earth. Imagine sending a message and waiting all night just to hear, "I'm okay." That was communication at the edge of space. But even in its silence, the mission represented something deeply human: patience. We are a species that plants seeds whose flowers we may never see. New Horizons was such a seed, sown towards a world many had dismissed, and yet it continued forward, unwavering. As the spacecraft approached Pluto in early 2015, excitement grew. Scientists watched their monitors like children on Christmas Eve. Cameras warmed, instruments hummed. After almost 10 years of travel, the moment finally arrived. Then, the first images came through. What appeared on the screens was not a blurry dot or a pale smudge. It was a world, detailed, colorful, alive with geography. Smooth plains, rugged mountains, glowing patches of red and white and charcoal. Pluto was no longer distant and theoretical. It had a face, and it was beautiful. The public reaction was electric. Social media exploded. News outlets roared. People who hadn't thought about space in years gazed at Pluto with awe. A world once dismissed was now a cosmic celebrity. The demoted planet had become the star of the solar system again. New Horizons did more than take pictures. It gathered data about Pluto's atmosphere, surface composition, geology, and moons. The spacecraft became our first envoy to the Kuiper Belt, a place untouched, unexplored, waiting to tell ancient stories about the formation of everything we know. The mission proved that curiosity does not fade with distance, and wonder does not require status. Pluto may have lost its planetary title, but New Horizons gave it something greater: identity. It was not a failed planet. It was a world of its own kind, mysterious, dynamic, magnificent in its strangeness. With every megabyte of data, Pluto whispered back across billions of kilometers, "You thought you knew me, but you never truly looked." And now, for the first time in history, humanity was finally looking. When New Horizons finally revealed Pluto's surface, one feature captured the world's imagination instantly. A vast, pale, heart-shaped region stretching across its face. This wasn't just poetic coincidence. It was geology speaking loudly, boldly, unmistakably. Scientists named this region Sputnik Planitia, a frozen plain of nitrogen ice, so smooth, so young, and so active that it shattered every assumption we had about dwarf planets. Before New Horizons, we imagined Pluto as a static world, cold, ancient, unchanging, a fossil of the solar system. But the heart of Pluto told a different story. Its surface showed few impact craters, meaning it is constantly being reshaped. Fresh ice flows like slow-motion rivers. Patterns form like wrinkles on a living skin. Something beneath the crust is warm enough, energetic enough, to move mountains of nitrogen and carbon monoxide ice. Pluto, against every expectation, was alive with geology. Sputnik Planitia isn't just a pretty shape. It's a mystery carved in frozen chemistry. The plain sits within a gigantic basin, possibly created by a massive ancient impact. Imagine something striking Pluto with enough force to gouge out a cavity nearly 1,000 kilometers wide. Over time, nitrogen ice may have pooled into this depression, like water filling an emptied lake. The heart may be Pluto's scar, healed but remembered. But here's where things become astonishing. This plane is not silent. Within its icy surface, spacecraft readings revealed convection cells, patterns like boiling water, except here the boiling happens over millions of years. Warm material slowly rises from below, cools, and sinks again. This behavior demands heat where there should be none. Pluto is tiny, distant, starved of sunlight. It should have frozen solid billions of years ago. Yet Sputnik Planitia pulses with movement. It is young, restless, impossible. The heart of Pluto may beat slowly, but it beats. And the colors, they tell their own tale. Surrounding regions glow with shades of rust red, created by complex organic molecules called tholins. These are forged when ultraviolet radiation interacts with Pluto's thin atmosphere, sprinkling the surface with red like cosmic paint. What we see as beauty is actually chemistry writing its signature across ice. Standing, hypothetically, at the edge of Sputnik Planitia would be surreal. Pale plains stretching to the horizon like frozen seas, mountains rising like towers of shadow, but not made of stone. On Pluto, water ice is so cold it behaves like rock, forming ranges that rival Earth's Rockies. The air would be faint, blue-tinted, whisper-thin. The sun would shine like a distant star, small but persistent, casting long shadows across glacial fields. This is not a dead world. It breathes slowly, sleeps lightly, dreams in ice. New horizons turned Pluto from a dot into a place, a landscape you can imagine walking across, hearing nothing but the crunch of nitrogen frost beneath your boots, and the faint sigh of a world so far from warmth that every flicker of energy feels miraculous. Sputnik Planitia changed everything. It forced us to rewrite what we expect from small worlds. It proved that even at the edge of the sun's faint embrace, geology can thrive and beauty can flourish. Pluto may be small, but its heart is enormous. While Earth dominates its moon like a parent towering over a child, Pluto's relationship with its largest moon is something entirely different, something almost poetic. Charon is nearly half the size of Pluto, so large in proportion that the two worlds orbit each other like partners, not ruler and satellite. Instead of one body circling the other, they both revolve around a shared gravitational point in space, a barycenter, located outside Pluto itself. This makes Pluto and Charon less like a planet and moon and more like a binary system, a cosmic duet. Imagine standing on Pluto, looking up. Charon would not drift across the sky like our moon. Instead, it would hang nearly motionless, forever staring back at the same face of Pluto, locked in gravitational embrace. The same is true in reverse. Anyone on Charon would see the same frozen face of Pluto, unmoving, eternal. Both worlds show each other only one side, forever. Their dance likely began billions of years ago when a massive collision stripped chunks of Pluto's original crust into orbit. Over time, the fragments coalesced into Charon. The impact also may have stirred heat within Pluto, contributing to internal activity we still do not fully understand. Two worlds born from the same violent moment and forever bound. This locked motion creates strange, beautiful consequences. There is a side of Pluto that Charon never sees, and a side of Charon that Pluto never sees. Permanent hemispheres, eternal day for one face, eternal absence of its partner for the other. An emotional symmetry, two worlds facing each other like lovers who refuse to look away. Charon itself is no passive sphere of ice. Its surface is split dramatically, one hemisphere pale and cratered, the other stained with deep reds. That red color is believed to come from Pluto's escaping atmosphere. Gas drifts toward Charon, freezes onto its surface, and transforms under radiation into tholins, the same organic molecules that paint Pluto's landscape. It is as if Pluto is sharing itself, exhaling chemical breath that seeds color across Charon's face. A cosmic gift. Geological clues suggest Charon once harbored a subsurface ocean. Cracks scar its surface like veins of ancient trauma, frozen memories of internal expansion when liquid turned to ice and expanded outward. Charon may be dormant now, but its past was alive. Two frozen worlds, both shaped by history, both still whispering hints of warmth beneath their shells. The orbit of Pluto and Charon is slow, majestic, patient. One full rotation takes more than 6 Earth days, a waltz in slow motion. Darkness around them is vast, but they move with purpose, tethered by gravity like two souls refusing separation. This system teaches us something profound. Greatness is not always measured in size or power. Sometimes it's measured in balance, partnership, and endurance. Pluto and Charon remind us that even in the loneliest regions of space, connection endures. Two worlds rotating together in the silent cold, keeping each other company at the very edge of sunlight. They are outcasts to some, planet and moon no longer, just dwarf and companion. But out here, definitions dissolve. Orbits speak louder than titles. Pluto is not alone. It never has been. In the vast Black Sea beyond Neptune, it dances, slowly, eternally, with Charon by its side. When most people imagine volcanoes, they picture fire, molten rock erupting in violent fountains. But on Pluto, reality bends into something stranger, colder, but no less dramatic. Instead of lava, Pluto's volcanoes may erupt ice, slush, and chemical mixtures so alien that no earthly landscape compares. These are cryovolcanoes, and their existence tells us one thing with absolute certainty. Pluto is not dead. It is active. It is evolving. One of the most impressive candidates is Right Mons, a mountainous structure rising kilometers above the surrounding terrain. From orbit, it appears like a giant blister, massive, lonely, and possibly hollow beneath its icy crust. Scientists believe Right Mons is a cryovolcanic dome shaped by upward surges of water ice mixed with methane, ammonia, or nitrogen. These are not eruptions of flame, but eruptions of cold matter, like a frozen ocean trying to reach the sky. The very idea is astonishing. How could a small, distant world with so little sunlight generate enough heat to drive volcanic movement? The answer might lie deep within Pluto's core, where radioactive elements slowly decay, creating warmth over billions of years. Another possibility is tidal interaction with Charon, especially in the early life of the system. That gravitational tug-of-war may have kneaded Pluto like dough, heating its interior, allowing liquid to persist where it should not exist. If cryovolcanoes are active, or even recently active, then beneath Pluto's surface may lie pockets or layers of liquid water. Imagine that, an ocean beneath ice, sealed away from the sun, warmed by the quiet heartbeat of a dwarf planet. An ocean where chemistry could unfold, where energy could dance, where conditions, maybe, could resemble the earliest whispers of life. This possibility changes everything. The surface around Pluto's suspected cryovolcanoes lacks impact craters, suggesting youth. Some areas appear almost smooth, as though resurfaced recently, a sign of geological renewal. Not billions of years old, but maybe millions, or hundreds of thousands. In cosmic terms, that is practically yesterday. Right Mons is not alone. Other features hint at similar processes: depressions, ridges, and flows that look as though icy slurries once oozed across the plains, and solidified like frozen lava. These landscapes speak quietly but boldly. Pluto still breathes heat. Compare this to Mars or our moon, worlds much closer to the sun, much larger, much older, yet geologically colder. Pluto, the outcast, behaves like a rebel, refusing to match expectations. It challenges the idea that distance equals death. It breaks rules without apology. Imagine standing there during an eruption, if eruption is even the right word. You would not see red fire or black smoke. Instead, you might witness slow fountains of freezing material bubbling upward, spreading like glacier fluid, then solidifying into pale ridges and domes. A silent eruption in a silent world. Pluto teaches us that worlds do not need sunlight to be alive. Heat can be born from within. Movement can occur in the coldest places. Life, maybe, could emerge in environments far different from our own Earth. Cryovolcanoes expand the definition of possibility, and Pluto, once dismissed as small and insignificant, now stands as proof that the universe hides its greatest wonders in its most unlikely places. This tiny world is not done surprising us. It is only just beginning to speak. Beneath Pluto's frozen plains, there may lie something unimaginably profound, something capable of turning a dwarf planet into a cradle of hidden possibility. An ocean, a real ocean. Not one made of familiar waves or warm blue waters, but a secret sea trapped far below the icy surface, an ocean of water mixed with ammonia and exotic chemicals that keep it from freezing solid even in the outer darkness of the solar system. While the surface burns at 230 degrees C, deep below, warmth may pool like a heartbeat, slow but persistent. This idea was once unthinkable. A world as small and distant as Pluto should have cooled long ago, frozen completely, static, dead. But the New Horizons mission shattered that assumption with one shocking discovery after another. The smoothity of Sputnik Planitia, the youth of its surface, the presence of potential cryovolcanic flows, everything pointed to an interior that was still warm, still shifting, still alive. But the strongest clue came from Pluto's shape itself. A giant basin like Sputnik Planitia should have caused Pluto to tip, to rotate so the heavy depression sat at the equator. And that is exactly what happened. Something dense beneath the basin pushed outward, acting like a mass of liquid resisting collapse, like a buoyant force, like an ocean. If that ocean exists, and evidence continues to strengthen the case, then we are looking at one of the most distant seas in the solar system. Not a shallow layer, but possibly 100 to 200 kilometers deep, encased beneath a shell of nitrogen frost and water ice crust. An entire world of dark, unbroken water. No sunlight reaches it, no wind stirs its surface. It lies under eternal pressure, unlit and unseen. But where there is water, there is always the whisper of another question. Could something be alive down there? Not life like ours, no plants, no fish, no familiar biology, but microbial life, primitive and persistent, fed by chemical gradients deep in the mantle. Similar ecosystems thrive on Earth at the bottom of our oceans, where hydrothermal vents spew minerals into the abyss, and creatures survive without ever seeing light. On Pluto, volcanic heat could provide similar energy, not flames, but warmth born of radioactive decay. A slow furnace driving circulation, feeding chemistry, nurturing possibility over billions of years. Because time is the one resource Pluto possesses endlessly. Imagine alien organisms evolving slowly in total darkness, single cells clustering near nutrient-rich fissures, life that never knew starlight but adapted to cold, pressure, and chemical sustenance. A biosphere hidden beneath layers of ice thicker than any glacier on Earth. The idea sounds like science fiction, yet science has been moving steadily toward it. Mars might have once had oceans, but they faded. Europa may have a massive ocean today, yet its surface is violently cracked by Jupiter's gravity. Enceladus sprays water into space, but its ocean is small and turbulent. Pluto, instead, offers something quieter, a stable ocean, ancient, protected, gentle in its isolation. If life began there even once, even faintly, it may have had billions of years to persist, adapt, and endure. We may never see that ocean with human eyes. Not soon, not easily. It sits too deep, beneath too much ice, too far from home. But one day missions will return. Cryobots may melt through the crust, diving into the Black Sea, carrying light where none has ever existed. And if they find life, even a microbe, even the smallest spark, then Pluto would change more than science. It would change us. It would rewrite our place in the universe. It would prove that life does not depend on warmth, sunlight, or Earth-like comfort. Life could survive anywhere, even in the silent heart of a distant dwarf planet. And suddenly, the cosmos would feel full, alive, crowded with possibility. Pluto is not alone. It drifts at the inner edge of a vast and mysterious realm, a cold frontier called the Kuiper Belt, a cosmic scrapyard left from the birth of the solar system. Think of it as the deep ocean beyond the shoreline, dark, unexplored, and teeming with objects we can barely imagine. What we once believed was the end of our planetary neighborhood turned out to be only the beginning. Out there, millions, perhaps billions, of icy bodies orbit the sun. Some are no larger than mountains. Others rival Pluto itself. These objects are more ancient than Earth, older than the planets, frozen time capsules preserving the chemistry of our cosmic origins. Touch one, and you touch the past. We used to think Pluto was strange. Now we see it as the first representative of an entire family. Names followed: Eris, Haumea, Makemake, Sedna, and more. Worlds with atmospheres that freeze and evaporate. Worlds shaped like rugby balls, worlds coated in methane frost, worlds with orbits so stretched they disappear into darkness for centuries. Some may even have oceans beneath their surfaces, just as Pluto might. Each one is a story waiting to be told. Beyond them lies something even more enigmatic, the scattered disk, where orbits twist like tangled threads and gravity behaves like a drunken architect. And farther still, so distant it may as well be myth, lies the Oort cloud, a icy sphere of comets surrounding the sun like a halo, extending almost halfway to the nearest star. If Pluto is a frontier, then the Oort cloud is the horizon. This is where the solar system fades into interstellar space, where the sun is only a brighter star in the sky. Objects out there may take millions of years to complete a single orbit. They belong to our system, yet they feel like visitors from another. And among these outward regions, whispers grow louder of something massive, unseen, pulling strings from the darkness. A possible Planet 9, a world 10 times the mass of Earth, drifting like a ghost. Its existence remains unconfirmed, but gravitational clues hint at a presence we cannot yet see. The outer solar system is not empty. It is a forest of worlds. Pluto opened the door. Before it, we believed the planets ended at Neptune, a tidy structure, 9 worlds, complete and comfortable. Now we know the truth is wilder. Our neighborhood is a sprawling empire of frozen spheres, comets with ancient hearts, and worlds that challenge our imagination. The discovery of Pluto was a beginning, not a conclusion. Every new observation pushes our curiosity further. Telescopes scan the darkness, looking for faint motions of distant objects. Spacecraft proposals dream of diving beyond Pluto, exploring dwarf planets like beads on a necklace. One day, a flotilla of probes may sail outward like ships of discovery, charting the unknown, world by world. And as we learn, our perspective shifts. Earth is no longer the center. The inner planets are not the whole story. The solar system is large beyond comfort, and Pluto is the key to its outer gate. A small world ignited a new era of exploration. A demoted planet became a guide to the most mysterious region we know, and the questions grow. How many worlds wait in the shadows? How many oceans lie beneath the ice? How many chances for life exist where sunlight never reaches? The outer darkness is no longer empty. It is full of worlds, of history, of potential futures. And Pluto stands at the threshold, silent but proud, as if whispering, "Come see what lies beyond me." Pluto's story is not about what it lost, it is about what it revealed. Even though it no longer holds the title of the 9th planet, Pluto has become something far more captivating, a symbol of curiosity, debate, and the evolving nature of science itself. Its reclassification sparked controversy, emotions, and endless conversation. Children wrote angry letters to NASA. Adults protested with T-shirts and petitions. Scientists argued passionately on stages and in journals. Why? Because Pluto is not just a world, it is an idea, a reminder that discovery is not static and truth is not frozen. Science is a living story. Pluto taught us that knowledge evolves, that definitions change as understanding deepens. Once we believed it, a lone planet. Now we know it as the shining heart of a vast frozen kingdom, the gateway to the Kuiper Belt, the key to identifying other dwarf planets, and the first step toward mapping the dark perimeter of our cosmic home. If Pluto had never been discovered, perhaps the outer solar system would still be a blank space on our map. But Clyde Tombaugh found it, and everything changed. Decades later, when new horizons raced across the void to meet this tiny world, humanity held its breath. People who had never looked at the night sky waited for images like they were waiting for news of a long-lost friend. Children stayed up past midnight. Scientists cried. The internet froze with anticipation, all for a world smaller than Earth's moon. When the first photos returned, that heart-shaped plane shining bright, Pluto touched something deeply human. A frozen sphere billions of kilometers away became a character, a story, a reminder that even the smallest things can surprise us. We found ice oceans where we expected silence. We found geological activity where we expected stillness. We found complexity where we expected simplicity. Pluto defies assumptions, and that is why we love it. It remains one of the most poetic symbols in astronomy. A world that lost its crown but gained immortality in our imagination, no longer a planet, yet more beloved than ever. And maybe, just maybe, that is better. If Pluto had stayed a planet, it might have faded into routine. One among many, familiar, defined, unquestioned. But by being challenged, reimagined, debated, and rediscovered, it became something unforgettable. The solar system did not shrink in 2006. It expanded. We learned that planets are not rare. Worlds come in countless types: rocky, gaseous, icy, volcanic, methane-rich, ocean-bearing. Pluto showed that classification is not about rejection, but refinement. Not about exclusion, but discovery. Every time we look into the dark outer regions, we are really asking a question Pluto inspired. What else is out there? One day, a spacecraft may return to orbit Pluto, not just fly past. It may dive across Sputnik Planitia, land on Right Mons, taste frozen nitrogen from the atmosphere, listen for echoes beneath the crust where oceans might whisper beneath ice. One day we might explore Charon's canyons. One day we might sail beneath Pluto's surface into a dark ocean warmed by unknown forces. What life could exist there? What chemistry could bloom in the cold? What secrets wait in the dark beneath a frozen heart? These questions live on because Pluto exists, not as a planet, but as a wonder, a world that shows how far we have come, and how far we still must go. Thank you for watching, explorers. This was FactFlow, and together we journeyed to the edge of our solar system, to a tiny world with a giant story. If Pluto amazed you, if the universe inspires you, then don't forget to like the video, share it, and subscribe to FactFlow for more deep space mysteries. Because adventure is just beginning, and every question leads to another star.